काही प्रश्न विचारायचे असतील तर तुम्ही सरांना विचारू शकता.
Palji, good afternoon.
यांना
Hello. I'm here.
Sorry.
At the first, I will thank you. I'm working in the field since last 25 years of electrical. I'm an electronic engineer, but working in the electrical field since last 30 years. I'm really appreciated the way you have explained the standard and details. And also proud that ECAM is also one part of the standard modification or standard generation. In this concern, I have few questions, not one question. First, as per IS 303, we have not found, or many people ask, we test the earthing, maybe at home, maybe at substation or transformer neutral, transformer body. We test the earthing and take the values. But people ask what are the reference values. If we get 1 ohm, 2 ohm, 3 ohm, many people has one thumb rule that earthing should be below 1 ohm. Many people ask what is the reference value that this earthing is okay. In this regard, I would like to bring your attention to guide us.
Sir, the standard is IS 3043. This from 1966 until 2018, the standard is never talking about connecting your transformer neutral to separately to earth pit. The standard is never talking about connecting the body of your DG or body of your transformer to separate earth pit. This was never written because it is against science.
But everyone is doing the same thing.
Yeah, this was it was a practice. As I said, the 1937 regulation, it was never changed until June 2023. The regulation, which is followed by the electrical inspectorate. So as a result, the documents which was followed by electrical inspectorate was almost 80-90 years old.
90-year-old.
But now, in the current regulation, 2023, the systems has changed. Now imagine each state, there are maybe 100 electrical inspectors. It will take at least 2-3 years for them to learn and to come to this level. It will take some time.
Secondly, right now in industry, majority our LEDs and everything, many times some malfunction happens. A person from CNC company comes and tells, I want a separate earthing and I want a neutral earth voltage below 1 volt. What is this concept?
An electrical apparatus which is having a metal body, class 1, class 2, class 3, there are 3 type of categories, 3 categories of electrical item. Class 1 is the equipment which need an earthing or equipotential bonding. Every class 1 electrical apparatus is able to work up to the nominal voltage between neutral and body. Means, even if the neutral to earth voltage is 230 volt plus 10%, equipment is supposed to work. This is written in IS 7302, which is the product standard. You can also find the information in, for example, the type testing of panel board. You can find those information. The manufacturer, after making the product, he has to apply a voltage between, for example, neutral and earth for certain time, and he has to operate it. The leakage current should be lesser than certain limit. Say, for example, 0.2 milliamps or 0.7 milli, depending upon the size of the device. So basically, for example, if you know some of the medical equipment, there is a medical equipment standard 60601. In that standard, it's very crystal clear. It has written that any live conductor, the potential between any live conductor to the protective earthing, the equipment must be able to withstand equipment may be able to work satisfactorily under the nominal voltage. Because the idea is, we have earthed system, TNTT, we have unearthed system, IT, means unearthed system. In case of an unearthed system, during the first fault, neutral to earth potential, distributed neutral to earth potential can be even 440 volt. And it can work continuously, and every electrical item is able to work at not actually 230, 440 volt continuously for certain time, 230 volt permanently.
Okay.
It is there, but the The wrong concept of neutral, 2 volt between neutral and earth will kill the equipment, 5 volt between neutral and earth will kill the equipment. These are actually the things which we need a lot of, fundamental change.
So people are denying your warranty period and charges. The people charge the customers. And what happens in that, we as a contractor come in trouble. Your earthing is not proper. You are not connected earthing proper. We want one below 1 volt. They does, I don't say, I don't understand, but the people does whatever they want. But they didn't give us the warranty claim and all those things.
Sir, actually this subject I would say, the whole market need change.
Okay.
Lot of change is required.
Okay.
Not only on this subject, as I said, I can explain 100 subjects from NEC, which is mostly, misinterpreted. So all these need correction.
This one dish organization is government dish. You might be a director of industrial and
Yes.
these people ask the electrical safety audit. Right now you said electrical verification of electrical safety.
Yeah.
Is there any specific designation or eligibility criteria for electrical engineers to certify that report or check that accordingly?
Yeah. Actually, if we look at the regulation, because this is not the job of NEC. Who is doing the job is not the job of NEC.
Okay.
NEC is explaining what you should do.
Okay.
Now, this is told in the regulation. Regulation, we can find two subjects. One is the regulation 6, which talks about chartered electrical safety engineer.
Yeah.
Every government, means the state government, is supposed to create a chartered electrical safety engineer. The qualification and the criteria are given. So basically, it is the job of the chartered electrical safety engineer to support the owner of the installation below notified voltage to self-certify the installation. If we go back, the responsibility of keeping the installation safe is it is the owner who has to make it safe. The chartered electrical safety engineer is helping the owner to make his installation safer. This is one. The second part, I think regulation 5 or 6, I don't remember exactly. Every electrical installation more than 250 kilowatt, they need to have their own internal, electrical safety officer or maybe an electrical supervisor, something like that. But what happened is, these two subjects are most of the state governments are reluctant to implement the chartered electrical safety engineer. Someone are showing that we are implementing, but it will take already 6, 7, 8 years gone. They could not make it. Maybe in next few years it may come. We don't know. We have to go and ask the government. The second one, based on this, 250 kilowatt and more, majority of the states, the owner of the electrical installation, he doesn't know that this provision exists.
Yeah, that is right. And in many times, some small notification comes from so and so day for transformer. Now onwards will require breaker only, no isolator. Again, right now, few days before, we got one electrical inspector notation or government GR that now onwards, all the residential buildings will require only a ester oil transformer or hermetically sealed transformers. So these single notification or rule, how come they comes from, where they comes?
Yeah. See here, for example, regulation 37, which is talking about circuit breaker.
Yeah.
For the point
distribution
of
transformers say earlier our rule or practice was like that below 1000 kVA transformer we were using isolator. Or fuse switch unit.
Yes.
Nowadays for every transformer which convert from 11 kV to 440 and having a consumer.
Yeah.
So this is again there is a difference. For MSC DCL installation where there are 630 transformers and all those things, they require AB switch and DO. When it comes to ST consumer, they ask the ST breaker.
Circuit breaker. It is like the same line, Discom can go for something smaller, cheaper, and the owner of the building or the owner of the installation should go for a circuit breaker, which is expensive. Why? To this, I have no answer, because this is also not the job of NEC. This is from the regulation, CA regulation. Okay. Now, once when we ask them, why do you made this change? So what they say is, these regulations will take certain years to get implemented. So also the regulation 38, bus bar trunking system, bus bar trunking for multi-storied buildings. So, but when we talk about, each of this change is creating a lot of confusion. Circuit breaker, of course, from the point of safety, circuit breaker is better. Nobody will deny that. Circuit breaker is better. It has got its own advantage. If we say that, that means the switch or the fuse switch, is it poor in achieving safety? No, that was also good. Now, why the CA regulation implemented or insisted for circuit breaker is actually, I am also trying to ask the same question to them. I am so sorry to say that we could not get any concrete answer from CEA regarding this. As contractors, of course, if we look at the legal system, contractors are the only legally protected people who can ask this question. You should go and ask to the electrical inspector, ultimately to the CEA. Similar is the situation, bus bar trunking, of course. Lot of fire accidents are happening in this, vertically, especially the vertical system. But then the challenge is whether the DISCOM is ready to take meter readings on every floor.
Exactly, that is the problem right now.
Yeah, this challenge is also going on. But then, nowadays, maybe after 2-3 years, smart meters will come and new technologies will come. And at that time, people will implement it. Time being, it's a confusion. But over a period of time, we have to clear it.
Yeah. My last request is that the way you have explained and all those things, if you can prepare a specific earthing chapter with refers to all these IS, and you can give us this for our engineers, all our contractors, it will be very helpful for us. If you can prepare and you can spare some time, that will coordinate later on. But if you say yes, that we will coordinate separately. I would like to request you only for earthing, if you can spare some time.
We can make it.
Okay,
Actually, we don't need to make anything. We have to extract the pages from NEC and give to you.
Okay.
So NEC part 1 section 18,
Okay.
with picture, whatever the pictures I have shown is from
Yeah.
NEC. The same pictures are there with explanations. That alone will clear your doubts. Part 1 section 18.
Okay, presently what I will
But
do, I will try my level best.
But
if I got-
specifically we can make one for you.
Yeah.
Not an issue. Maybe for I can give to the management and they can distribute and all can use it.
Yeah. Thank you, sir. From
Thank
my
you.
side, and thank you.
Bonding, do you mean to say the path to the earth can be eliminated? Can only equipotential bonding suffice?
Yes.
You do not need to provide a path?
You don't need the soil to take the fault current back to the source for low voltage electrical installation. We are not talking about high voltage, extra high voltage. Transmission is a different system.
Right. So, electrical systems, equipments, they will have inherent leakage for whatever reason. And it cannot be 100% leakage proof.
Yes.
So, where does that current go as per your concept that there should not be an earth conductor or the equipotential will suffice?
Yeah.
Where will that leakage current go?
Whatever
It is
the
bound to
current.
be there. The system cannot be rid of the leakages.
Yeah. First of all, it's not my concept. It is from the standard IEC 60364, which is used globally. So this idea is not mine. Please, I would like to correct. The second one is the current leave the source and return back to the source, including the leakage current. It has to go back to the source. That means, for example, in a typical case, to the neutral of the system. Now, continuous leakage current of more than certain amplitude will create fire, shock, as well as electromagnetic problem. This particular limit for AC is 10 milliamperes. If the leakage current from an electrical apparatus is more than 10 milliampere, especially for electronic devices such as SMPS power supply, which is using a filter capacitor, there the current is more. There, we have to implement a reinforced protective measure. Means, the leakage current, you route it through an insulated conductor back to the neutral of the source. So if the leakage current is more, say for example nowadays multi-storied building, lift, the VFDs which is using, sometimes the regenerating VFDs, leakage current is more than an ampere. Imagine 6-7 lift in one building.
Exactly.
Total leakage current is maybe 6 amperes. That leakage current we have to, because the manufacturer knows from where the leakage is coming. He has to route the leakage current back to he has to provide 2 separate terminals in his panel board, let's say lift panel, 2 separate terminals, One terminal is to handle the leakage current, another terminal is to handle the shock voltage. So that leakage current has to be taken separately through an insulated conductor to the MET of the system. You can find it in IS 732.
There are many equipments now made which are not.
Sir, if you use the mic, it would be.
Sorry. There are many equipments now made which are fully insulated, which do not have any metal parts.
Yeah.
Now, in such installations, would only the two conductors suffice, or is the third conductor
These
still
are called as
necessary?
class 2 device. Class 2 or reinforced insulation or double insulation.
Double insulation.
So double insulation devices, you don't need any earthing. It's earth free. Similarly, the next category is extra low voltage, means less than certain voltage. The voltage is not able to create shock. In that case also you don't need to have an earthing. But there is another subject which is called as functional earthing. Means the electronic, the microprocessor in the PLC, for example, you have a meter and maybe the meter is having a microprocessor, and that microprocessor may need a reference potential. In that case, class 2 device may require functional earthing. So you have to find out whether functional earthing requirement is there or not. In that case, a set of additional rules apply. So you have to handle it separately. Not to the pit, you have to put a separate wire to the common bus bar.
So again, as far as the specification state that it has to be equipotential at all the points. That's what it states.
Yes.
There is no concept of taking the fault current or the leakage current into earth,
Correct.
right?
Correct.
Okay, thanks.
Last question, huh?
Sir, I'm very sorry. After this marathon question answer session, I don't have any time to ask you. Only thing I will highlight, one thing is that as you said about the neutral to earth voltage, right?
Yeah.
So it is, according to my understanding, it is due to third harmonics or tripling harmonics currents. So it is nothing to do with the fault current. So it can be accepted as 2 volt, the voltage between the ground and earth. If I'm not correct, you can definitely rectify me. That is number 1 point. Now I am going very fast, otherwise time is not there. Second thing, regarding equipotential, you are very clearly told that it is for only building and other installation where supply voltage is 440 volt or 415 volt or 230 volt divided by root 3, right? For other high voltage application, it has to be separate. Their ground current will flow. If you connect a lightning arrestor with the body, then in case of lightning, the current is order of 300 kiloamperes. So 300 kiloamperes current, that means the corresponding voltage will get installed in the body of the installation, transformer
Sir,
or
sir,
motor.
I understood. Shall I answer?
Yes, sir, please.
The first question about the 2 voltage, the question was not why 2 voltage or 5 voltage. The question was whether the equipment is able to work under the 2 voltage or 5 volt was the question. So what I answered is, every electrical equipment between neutral, means a live conductor, to its body, means the body of a class 1 equipment, even if the voltage is 230 volt, the equipment is supposed to work. I didn't spoke about whether the voltage is due to leakage or fault or harmonic. That is the question as well as my understanding and the answer was different. Number 2, equipotential bonding is the only method irrespective of voltage. Whether it is low voltage, high voltage, extra high voltage or whatever the voltage, generating station or whatever, including solar PV and all. Lightning protection, the neutral of the system, if it is there, plus exposed extraneous conductive parts must be interconnected is the only principle. Now, transmission distribution substation, due to the distance of the fault current, a conductor carrying current, the resistance of the conductor may be more than the electrode resistance which we can achieve locally. So, for example, a transmission line at the source as well as the downstream, both the places, we have to make a localized equipotential bonding, interconnecting all metal. The only point is the fault current which has to go back to the source, it will go through the soil. So, while this potential during fault, while this current is flowing back to its source or at the original station, once when a fault current reaches this particular point, high step and touch voltages are created. So the equipotential bonding in that localized area should be made in such a way that touch and step voltages are reduced so that there is no shock. Otherwise, everything together is the only method. Now, to go one step ahead, city centers, where you have substations within the city centers, the new method is called as global earthing system. Global earthing means all the metal parts, including the rebars, the several multiple buildings, lot of steel, tons of steel. You interconnect all the steel together so that there is no shock voltage. So, a lot of new concepts also came. I hope I answered your question. Okay.
Thank you so much, sir, for guiding us on this very important topic. Thank you very much. आणि आभार प्रदर्शन करण्यासाठी मी श्री सचिन फडतरे यांना इथे आमंत्रित करते.
हॅलो. नॅशनल इलेक्ट्रिकल कोड ऑफ इंडिया च्या रेग्युलेशनबद्दल जी आपल्या सर्वांना माहिती दिली आणि महत्त्वपूर्ण माहिती होती, त्याच्याबद्दल मी गोपा कुमार यांचे विशेष आभार मानतो. आणि एक संघटनेला अभिमान आहे की आपण ज्या BIS कमिटी नॅशनल जे कोड्स तयार होतात त्याचे आपण पदसिद्ध मेंबर्स आहोत आणि संघटनेचे अध्यक्ष म्हणून इलेक्ट्रिकल कॉन्ट्रॅक्टर असोसिएशन आपण त्याचे मेंबर आहे आणि त्याचं रिप्रेझेंटेटिव्ह सध्या आपले उल्हासजी वज्रे साहेब करत आहे. त्याचा आम्हाला सार्थ अभिमान आहे. थँक्यू सर.